Hi, everybody. Today we're doing P9, which says we're going to write a formula for recursive sequence. Fortunately for us, it's more identify the right formula. So I previewed it, which I usually don't do because I like it to be a surprise. But I wanted to take a look at this one because a recursive sequence formula is very difficult to write by itself. But it should be pretty easy to identify the right one. Basically, we just have to know what we're looking for. Now, as we go through this, we're looking for differences through multipliers or through differences of sums. And what's happening here is we added 7 from 12 to 19. We have a difference of 7, so we added 7, and then we added 7, and then we added 7. So we're adding 7 every time. We're taking the one before and adding 7 more, which would be this one right here. This one says, take the term before and add 7 more. Sorry, I shouldn't have underlined that yet. Okay, so in this one, this time we have 2 more and 2 more and 2 more. For those of you who are aware, these are even numbers, aren't they? And some of you are aware, n plus 2 would be the formula if we were doing the explicit formula, which also describes even integers, n plus 2, and 2 more is n plus 4, and so on. So we're looking for adding 2 to the term before. So if you look at the term before and add 2, it works every time. That's what this little n minus 1 means. A to the n minus 1 says take the term before and add 2. Hopefully that's enough explanation, since you've probably been doing the others. All right, in this one, we added 4, added 4, added 4, added 4, and so on. We can see that we took 15 plus 4 and got 19. We took 19 plus 4 and got 23. We added 4, and so we are adding 4 every time, and there it is right there. We're taking the term before and adding 4. Now this one's a little bit different. It looks like we added 13 this time. Even though we started at negative 10, we added 13, we added 13. You could probably see it better in that pair. We added 13 every time, so there it is. The arithmetic are pretty easy. It's when we have to do the multiplier that's a problem. All right, so in this one, it looks like we added 8, didn't we? 3 plus 8 is 11, and 8 and 11 is 19, and so on. So we're adding 8 every time. It looks like they started out with, I don't know why that thing's there. I need to get rid of this. I don't know what that thing's for. All right. Oh, this time we're doing a multiplier. So we're multiplying by 3 every time, aren't we? You see, this one has a difference of 10, but this one has a difference of 30. So we're multiplying by 3, we're multiplying by 3, we're multiplying by 3 every time, which means that we take the former term and we multiply by 3 to get the next term. This is called a recursive formula. There it is. In this one, we multiplied by 2, not 5. We multiplied by 2. Notice that the differences are changing. That means we're talking about a multiplier. And we multiplied by 2 each time. This is a geometric sequence, not an arithmetic. In arithmetic sequences, all the numbers have the same difference. This one, the numbers are, the difference between the numbers is changing. And we're multiplying by 2 every time, and there it is. If we were multiplying by negative 2, then these would be negatives, wouldn't they? Actually, they'd be alternating negatives, but there you have it. Okay, so this time we multiplied by 7. This first one is pretty easy to see. The next one's a little harder, but if you multiply by 7, you do get the 196. We multiply by 7, and sure enough, we get 1372. So we're multiplying by 7, and there it is. In this one, we're multiplying by 4, and we multiply by 4, and we multiply by 4, and there it is. I think some people may be sticking the numbers into the formulas and seeing if they can figure it out from there. Now, this one is a little more difficult, but if you look at the 15 to the 45 over 4, or even better yet, the 45 over 4 to the 135 over 16, I'm going to use the 15. And what I want to do is I want a multiplier. This is obviously being multiplied by something, and it looks like it's a fraction. And I get 45 over 4. Well, 15 is really 15 over 1. So the question is, what did I multiply by to get the 45 over 4? And in this case, I multiplied by 3 in the numerator. 15 times 3 is 45. And I multiplied by 4 in the denominator. One way of finding that is to take 15 and divide it by the previous term. 15 over 20 is 3 over 4 when you do that division. And that is your multiplier. So if you know it's a geometric sequence, you can divide it backwards and find your multiplier that way. 3 over 4 is my multiplier, and there it is right there. Watch out for those alternating negatives, because then our multiplier is negative. In this particular case, we're adding zeros. That means multiplying by 10, by the way. We multiplied by 10, we multiplied by 10, we multiplied by 10. And multiplying by 10 is located right there. We want to recognize those geometric sequences. This is a recursive formula, which is different than our geometric formula that we had with the explicit one. This is called recursive. We're using something from before. Now this one, again, it looks like we're dividing by 3, but that's the same as multiplying by 1/3. And notice this pair right here tells us almost exactly what we need to do. We're multiplying by 1/3, and there it is right there. Hopefully you can see it. Some people are going to say, well, wait a minute, didn't I divide by 3 and got 25? That's true, but dividing by 3, remember, is the same as multiplying by 1/3. And in this particular case, we want to multiply by a multiplication, a multiplier. Then there it is. Hopefully the bells aren't too distracting. All right, looks like we're multiplying by 1/4 this time. And again, this pair kind of gives it away. So we're multiplying by 1/4, and oh, we have to write the recursive formula for real this time. So we want a to the n is 1/4 times a to the previous term, which is n minus 1. And there it is. So let's put it in. Let's see what they give us. They should give us, oh, there it is. A to the n, or an is equal to 1/4, and I'm going to use the fraction bar. Oops. Oh no. Okay, I have to undo this, and maybe if I touch it, no. Okay, I've got a little issue here. I'm still down next to the n, so I have to find a way of undoing that. So I'm thinking that I have to touch it. There we go. You see the difference? Before my cursor was small. Now I have a to the n equals, now I want the 1/4, and I'm going to use the fraction bar, 1/4. I could use the division symbol, the slash, but you're probably better off making it really nice. This is a nice recursive formula. And I don't have to put the parenthesis. I could put times if I want to. I could use times, or I could just leave it as a to the n minus 1. I'm going to go ahead and put, usually I'd put parentheses. I don't see them. So I'm going to put the times a, and then I need an n minus 1 in this little spot here. And notice that I kept it there. And there it is. Little tricky putting it in, isn't it? So we did end up writing a formula for recursive sequence, at least eventually. All right, it looks like we are multiplying. Nope, we're not multiplying, we're adding. This is interesting. What did we do? Did we multiply by -2? No. Did we multiply by, what did we do? We multiplied by -2? No. -3 to 6. If you add 9, oh, we added 9, didn't we? I just couldn't see it. I was into the multiplying. We're adding 9 every time. There it is. Duh. Plus 9, plus 9, plus 9. We're adding 9 every time. So we take a to the n is equal to a to the n minus 1 plus 9, isn't it? So there's our formula. A to the n, use the cursor, equals a. Takes a little while. It just takes practice. Cursor plus 9. Looks good. And I'll erase this so you can see it a little better there. There, it looks a little bit nicer. You see that I wrote it first and then I type it in. The typing in takes the longest, I think, more than the problem itself. Hopefully they won't give us too many to do. All right, this time looks like we are multiplying by 1/6. And it's a little hard to see for the 18, isn't it? To the 3 and the 3 to the 1/2. But from the 1/2 to the 1/12, it's clearly 1/2 times 1/6. 1/2 times something gives us the 1/12. And this is probably the easiest place to see it. It is 1/6. Now, this one we divided by 6, and this one we divided by 6. But multiplying by 1/6 is the same thing. So clearly we're taking the previous term and multiplying by 1/6. So a to the n, I'm going to write it, equals 1/6 a to the n minus 1, and I'll go ahead and put it in. I'm going to get rid of my, there. That way I'm not writing kind of funky there. So we have a to n, and I'm not going to say a to the n because that's an exponent. So I'm going to call it an, okay? Equals a n minus 1. Oh, dang it, I thought I hit it. I got to put it in. There we go. N minus 1. And then, oh, I forgot to multiply by the 1/6. Let's put it in the beginning. Now I could have said times 1/6, but generally we like to put it out in front because it is a coefficient. Man, I really messed that one up. There it is. 1/6 times a to the n minus 1. No negatives alternating or anything weird like that. All right, this time it looks like we're multiplying by 1/2, and I'm just going to go ahead and see if I can type it in. So I have an, cursor equals, this time we're multiplying by 1/2. Oh, got to do the fraction bar first. 1/2 times a, and we need an n minus 1, don't we? And there it is. We're multiplying by 1/2 each time. And again, this one gives it away, that second pair, doesn't it? That pair right there. Right there gives it away. I multiplied by 1/2, which is the same as dividing by 2. Anyway, there it is. Get rid of this. Oh, maybe I'll leave it on so I can write. All right, we divided by, oh, it's hard to see in this one because you didn't really divide by something. We multiplied by 2/3, but it's hard to see until we get to here. This pair, I think, gives it away. You see, I have 52/3, and I multiply by something, and I get 104/9. And I think most of you probably can see that I multiplied 52 times 2, and I multiplied 3 times 3, so my multiplier is the 2/3. Now, one thing a lot of people are going to get scared about is that they're going to think, oh, but doesn't 3 go into 52? Well, we know it doesn't because 5 plus 2 is 7, and 3 doesn't go into 7. But I also know because they write their fractions in lowest terms. And so because I know that 3 doesn't go into 52, or they would have simplified it. That's another way to tell. 3 does go into 51 17 times, but 3 does not go into 52. You have a 1 remainder. So we have a 2/3. So it's an equals 2/3 an minus 1. And I'm going to go ahead and get rid of this guy. So I've got cursor equals 2/3. I'm getting better at typing this. Times, I need the cursor times, an minus 1. There it is. 2/3. Now this one, 9, 12, 15, looks like I'm adding 3. Bit too easy, huh? Plus 3, plus 3, plus 3. So let's just add the 3. An equals an minus 1 cursor plus 3. Looks like I'm adding 3 every time, and sure enough, it looks good. In this one, we multiply by 6, multiplying by 6, multiplying by 6, multiplying by 6. So we take, I'll write it, and then I'll type it. An equals 6 times an minus 1. There it is. Get rid of that. We've got an cursor. Oh, what did I do? Dang it. There. Equals 6 times an minus 1. There it is. And we're getting there. I always say that at the 90s. All right. This one are all negative, so it's not an alternating negative situation. It's just negative. And it looks like we're adding, no, we're subtracting 7, minus 7, minus 7, minus 7. Another way to think of that is adding a negative 7, which is the way I like to think of it. But it's going to be minus 7. So it's going to be an equals an minus 1 minus 7. We're subtracting 7, and hopefully you can see it through whichever pair, it doesn't matter. So there it is. I'll put it in. An cursor equals an minus 1 minus 7. Now I could put plus negative 7. It would have been the same thing. Oh man, they're going to make us do a bunch of them. All right. Looks like minus 4, minus 4, minus 4, minus 4, minus 4. We're just subtracting 4 every time, so I'm just going to type it in. An equals an minus 1. Oh, 1. Don't forget the cursor. Minus, and we're subtracting 4 every time. Let's see what we're doing this time. Oh, interesting. Okay, we're alternating negatives. So the multiplier is the negative. That's always the case whenever you have an alternating situation, because I multiply by the negative 1/3, we get a negative. Then when we take the negative and we multiply by the negative 1/3, we get the positive, and so on. And this one is probably the clearest pair right there, or maybe right here. You can see the multiplier here for sure, because 1 times negative 1/3 is negative 1/3. So whichever pair, you can see it hopefully. And we're talking about an equals negative 1/3 an minus 1. Now, a lot of people put their negative out in front. I prefer the negative in the numerator. So I am definitely going to put my negative in my numerator where it really belongs. Let's get rid of that. We've got an cursor equals. I need a fraction, and we need a negative 1/3. And it's times a to the n minus 1. Man, I can almost type this fast now. Everybody see it? There it is. Looks good. This time we're multiplying by 5. These should be very familiar powers of 5, and I recommend memorizing this one. 5 squared is 25, times 5 is 125, times 5 is 625, times 5 is 3125. I would memorize these first 4 or 5 powers of 5. Really nice to know your exponents, but we're just multiplying by 5. So we have a multiplier, and we're talking about a and cursor equals 5 times a n minus 1. There we go, multiplying by 5. Okay, we're adding what, 12? Yep, adding 12, adding 12, adding 12, adding 12. Not that scary. Plus 12, plus 12, plus 12. So I'm just going to type it in. A n cursor equals a n minus 1 plus 12. That's all. In this one, it looks like we added 6, plus 6, plus 6, plus 6, plus 6. I'm just going to type it in. A n cursor equals a n, oh, I should have typed the a first, n minus 1, then it automatically goes there. It makes it a little faster. And what are we adding? 6 plus 6 plus 6, yep, plus 6 plus 6 plus 6. And we've got times 3, times 3, times 3, times 3. No, not times 3, times 9. There it is. Times 9, times 9, times 9. 9 times 9 times 9 every time. So we're multiplying by 9. 9 is our multiplier. We have a to the n equals 9 times a n minus 1. Notice that if you type the a first and then hit the, if you type the a first and then hit that key, the a to the n key or the subscript key, then it automatically goes into the subscript and you don't have to sit there and try and make it work out for you. Just makes things easier. And we are multiplying by 9. Nothing like double checking there. All right, maybe 2 more. Looks like 2/5. Now, how did I do that so fast? Because 38 is getting multiplied by 2 to get to 76. But I'm also have a 5 in the denominator, so I know it's 2/5. But here's another way to tell. I've got 76 over 5, and I want to have a multiplier, and I'm going to get 152 over 5. Well, clearly, sorry. Yeah, that's right. Over 25, sorry. There we go. I multiplied the numerator by 2. 76 times 2 is 152, and 5 times 5 is 25. That may not be perfectly clear to a lot of people, and it's really hard to see from the 95 and the 38. But again, if you put the 38 over the 95 and you divide by 19, which again is not obvious to a lot of people, you're going to get 2 over 5. Some people are going to grab their handy dandy calculator and they're going to say, oh, I divide backwards. So 38 divided by 95 is 0.4. So they're going to use 0.4 and they might get it wrong. I don't know if it'll allow it. I would use 2/5 instead of the 4/10. But anyway, there you have it. Let's take this off. Our multiplier is 2/5. So we're talking about, remember, type the a first, then the subscript, then the cursor, and then we want the 2/5. So we need a fraction times, I don't think you need to write the times, but I think it's easier. And then if you type the a first, then when you type the subscript, it puts it in there for you. And that's your n minus 1. So it's times 2/5. And we have one last one. Hopefully you guys can get it. And okay, we're alternating negatives. I hope you saw that right away. So our multiplier is going to be negative. And I'm going to look at this pair, just like I did last time. Look at that pair right there. That's probably the easier pair, because I took negative 64 over 1 times a multiplier. And I got positive 128 over 3, didn't I? Well, to get that positive 128, I need a negative 2. And to get that 3, I need a 3. So my multiplier is negative 2/3. Probably not that obvious from the first pair, but hopefully that second pair helps you out. Anyway, that's my multiplier. And of course, we're talking about, let's put them in. A subscript n, cursor, 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 I said, equals, we're talking about negative 2/3. So fraction, negative 2 over 3 times, oops, cursor, times my a subscript n minus 1. There it is, negative 2/3. And I hope you guys can get it and get to your 100 and master it. And I'll see you back sometime. Bye, everybody.